Welcome back to Golang for Devs. This video will cover everything you need to know about list types in Go. So let's get at it. All right, unlike some other languages, there are two list types in Go. The first is arrays, which are lists of a fixed length, and the second is slices, which are lists with a dynamic length. Arrays in Go are value types, meaning they store the underlying data directly. And when you pass them to a function, the whole array is copied. And again, they have a fixed length, which means they can't grow or shrink. But you can modify values at each index after the array is created. In contrast, slices have a dynamic length, so they can grow and shrink. They are also reference types, meaning they store a pointer to an underlying array that actually holds the data. So when you pass a slice to a function, only the pointer data or the slice descriptor is copied, and the array backing the slice is not copied. This is an important point because if you modify a slice that you pass into a function, the original slice that is used to call the function will also be modified. And I'll go over how to prevent that scenario in a bit. In practice, you'll almost always be using slices and not arrays. Okay, let's get to some actual code. You can create both slices and arrays in a similar way. You can create an array with the var syntax like this, and you can create a slice in the same way. The only difference is that for an array, you have to provide the length because it can't grow or shrink, so you have to allocate it up front. For a slice, you don't provide any length. Shorthand instantiation also works too, and works the same way for slices without the length. You can also use the built-in make function to create a slice, but it only works for slices. And you need to provide the length and the capacity. And I'll go over what the length and capacity of a slice are shortly. Okay, another difference between arrays and slices is the zero value. For arrays, the zero value is a full array consisting of the zero values of the type that the array holds. So in this case, for an int array, Go will instantiate it with a bunch of zeros. If you do the same thing with a slice, though, the zero value will be nil. And it's important to not confuse a nil slice with a slice that's just empty. So this produces an empty slice with a length of 0, but the slice itself is not nil. Okay, accessing and modifying indexes in a slice or an array works with the same square bracket notation that you'll see in a lot of other languages. So if I have an array and a slice and I want to access them, I can do it like this. Super simple. And then you can modify in the same way. So if I want to change the value of the array at index 1, I just do it with square brackets like that. And same exact thing for a slice. Okay, next up is getting the length of a slice or an array. And you do it the same way that you would with strings by just using the built-in length function. So that will return 3. And same thing for the slice. It's also worth noting that checking the length of a nil slice will return 0. So it's considered best practice to use length checks instead of nil checks to see if a slice is empty. All right, iterating over arrays and slices. It's the exact same syntax for slices and arrays. And you do it using the for range loop, which gives you an index and the value at that index. And you can print those. Another thing you can do with slices is add values to them using the built-in append function in Go. So if I have a slice, I can use the append function to add a value to the end of it. And the append function returns a new slice, but the slice is referencing the same backing array. And again, this doesn't work with arrays because arrays have a fixed length. Okay, next up is copying. And like I mentioned earlier, if you pass a slice into a function, only the reference to the backing array is copied. The actual data is not copied. So if you modify a slice in a function, it will modify the original slice as well. If you don't want the original to change, you need to make a copy of the slice that was passed into the function. So first you create a slice with the same length as the slice passed in, and then you call copy to copy the values from the slice passed in into the new slice. So the first argument is the destination slice, and the second argument is the source slice. And copy returns the number of elements that were copied into the slice. So with all those operations, arrays and slices work pretty similarly, but it's important to understand exactly how slices work under the hood. So internally, slices are stored as a slice descriptor, which has a data pointer that points to the index that the slice starts at in the backing array. So in this case, it's pointing to index 0 in the backing array, but it can start at any index in the backing array. Then there's the length property, which tells you how many elements from the backing array are included in the slice. So in this case, with a length of 3, the first 3 elements are included in the slice, even though the backing array has a size of 6. And last up, the capacity is the total size of the backing array. So functionally, this slice has 3 elements in it, but it has capacity for another 3 elements. The length and capacity of a slice are the most important concept about slices to understand, because if you append enough values to a slice to go over the capacity, Go needs to reallocate the entire backing array with extra capacity. So if you're not careful, you can introduce performance issues where you're continuously reallocating memory for new backing arrays. And if you find illustrations like this helpful, consider liking and subscribing for more content like this. You can also find this diagram in the repo linked in the description. All right, so let's do an example illustrating the performance issues you can hit if you don't take capacity of a slice into account. So let's say I have a function that continuously appends values to a slice. So we allocate an empty slice, and then we have a for loop that appends a value to the slice on every iteration. For small slices, Go will double the capacity every time it needs to grow the backing array. So reallocation won't happen on every single loop iteration, but it will still impact performance. And the fix for this is super straightforward. You just need to pre-allocate the array with a specific capacity. So in this case, we give the initial slice a length of 0, but a capacity of 100. So when it's instantiated, the backing array already has capacity for 100 elements. So when we append in each loop iteration, no reallocation is required. So the TLDR is, if you know how big a slice is going to get, you should always use make to create it and set an initial capacity. Okay, so now that you understand slice anatomy, we can talk about slicing. It works the same way that slicing for strings works, using the same square bracket notation. So the first number is inclusive, so the slice will start at index 1, and the second number is exclusive, so the slice will end at index 2. And like with strings, you can drop the first number or the second number in the square brackets. So if I drop the first number, it will start at index 0 and end at index 2 in this case, because the 3 is exclusive. And if I drop the second number, the slice will end at the last index in the original slice. And it's worth noting that slicing works with both arrays and slices, but it always returns a slice. It also never copies the backing array, so the same underlying data is referenced by the new slice. So because it references the same backing data, if I make a slice from this original slice using the first two indexes, then the capacity in the slice that is returned will be 5, because the size of the backing array is going to be 5. But you can artificially limit the capacity of the new slice using a third number in the square brackets. So this will give me a slice with the first two indexes, but the capacity is going to equal 3 instead of 5. This is really only useful if you need to append to the new slice without modifying the original slice as well, because the limited capacity will force the Go runtime to allocate a new backing array. Go also has a slices package in the standard library that has a bunch of useful functions for working with slices. I'll cover some of the basic examples here, but I'll leave a link to the docs in the description if you want to go deeper. Okay, first up, we are going to use the clone function. Unlike the built-in copy function I showed you earlier, the clone function will allocate a new slice all by itself, so you don't need to pre-allocate. You can concatenate two slices together using the slices.Concat function. Next, you can remove elements from a slice using the slices.Delete function, where the first number here is the start index that you want to delete from, and the second number is the end. And like slicing, the first is inclusive and the second is exclusive. So this would remove index 0 and 1. The deletion itself works by copying and shifting the values in the backing array to the left. So no new array is allocated when using the delete function. And similar to deleting, you can use the DeleteFunc function to filter a slice. So this accepts the slice you want to filter and a function that returns a Boolean. And if this function returns true, it means the value will be filtered out of the slice. You can insert values into a slice using a similar insert function. So here I'm inserting a value at index 1, and the value being inserted is 4. This one works by copying and right shifting the values in the backing array. So unlike the delete function, if the capacity isn't large enough, this will reallocate a new backing array. The slices package also has a bunch of functions for sorting slices. You can do a basic sort on a slice using the slices.Sort function, which may or may not swap equal values. Or you can do a stable sort using the sort_stable function, which accepts a slice and another function that accepts two values and returns an int. The function should return -1 if A is less than B, and it should return 1 if A is greater than B, and return 0 if the values are equal. And one more sort method example, you can use the slices.isSorted method to check if a slice is already sorted. You can't use normal comparison operators to compare slices in Go. So the standard library gives you some functions to do comparisons with. First, you can check if two slices are equal by using slices.equal, or you can compare them using the slices.compare function, which returns 1 if S1 is greater than S2, 0 if S1 equals S2, or -1 if S1 is less than S2. The last thing I'll cover on the standard library in this video is searching. You can get the index of the first occurrence of a value in a slice using the slices.Index function. So this will give you the first occurrence of 2 in the slice. And then you can check if a slice has an element in it by using slices.Contains. So this will return true if the slice contains 2. There are a ton of other functions in the slices package, so I highly recommend giving that a read through. It's a super important part of the Go ecosystem. But that is more or less all you need to know about using slices and arrays in Go. Thanks for watching, and if this was helpful, don't forget to give a thumbs up and subscribe. As always, keep breathing, keep building, and I'll see you in the next one. Peace out.